Let's now explore another IT field known as computer forensics. The role of computer forensics is to secure and analyze evidence of computer crimes. What could constitute a piece of evidence? If you suspect an attack has been launched on your system, you need to document the current configuration of a targeted computer. Any sophisticated tools are redundant. It's enough to deploy a script written in a language of your choice, PowerShell, command line, etc. The script collects data on current configuration, launched processes, listening ports for your computer, network activity, and so on. Network traffic log has great value as evidence in computer crimes investigation. Even the local attacks usually are dependent on a network activity of some kind. Data transmitting. A launched program communicates with the control center or is updating. Examining network traffic is a simple and effective method for documenting attacks. We'll show how to do this using Wireshark Sniffer. The gathered data will only be legally effective if a court is convinced of its authenticity. It's not enough to collect some data and testify that it's been sent out of your computer. We need to be able to prove in some way that the log is really the network communications log of your computer. A good solution is to sign the gathered communications files. We'll learn how to do that in a minute. Another good practice is creating a low-level disk image. A lot of professional forensics tools set out by performing this action. The programs duplicate the whole logical disk and sign the created file. From that moment on, we can access data and metadata in different ways. Before you report on a cybercrime, you need to first secure your evidence. Then, the collected evidence has to be examined. This is, in practice, delegated to professional entities specializing in computer forensics analysis. The roles of user and administrator are usually limited to securing the gathered evidence. The role of a person who analyzes the collected data is to document an attack for legal use. Let's discover how to verify the authenticity of files through their signatures. The internet is full of specialist programs that calculate file checksums, such as, for example, ExactFile. One of the strengths of this application is that it's capable of calculating a checksum for the entire directory. You only need to specify the location of files whose authenticity you're trying to maintain. Next, select checksum format. Files are usually signed using one of the versions of the MD5 and SH algorithms in the internet. We'll select SHA1. Next, we choose the option that generates file signatures, Create Digest. In this way, a signature for all the files that are contained in a specific directory will be created. The picture below shows checksums for all the files. This is a great utility for documenting system legacy. It is better applied to documents than to system files, as the latter are often modified on a regular basis. Once you've generated a checksum for the files and a modification is understood as an attack, this would end in a flood of false positives. There has to be another solution for system files. Checksums are effective for ordinary files. The best solution would be to verify the checksum for all read files that come from an untrusted source. A trusted website should also be considered an untrusted source. Files downloaded from these sites should be treated as an untrusted source for binary files. As far as system files are concerned, it's good to use the SIGCheck program. This is a tool that is a component of the sysinternals package. It's launched from the command line run as administrator. The tool was developed by Mark Rusinovich. SigCheck allows us to verify digital signatures for all the files in a selected location. It covers either all the files or only the binaries. System directory should not contain any unsigned files or files that are signed in an incorrect way, or that used an invalid certificate for generating their signatures. All checksums have to match. Let's run a quick test for the system directory. To scan only the binaries, select the E option. We'll also check the signers of the files, the I option. The test results show an example of a correctly signed file. You can view the issuer of the certificate used to sign the file and see if the certificate is trusted. We'll add the U option to the submitted expression. This command should not return any results. As you can see, all files are signed and all signatures are correct. Using this tool, you can check the authenticity of key system files on a regular basis.